Let's discuss about insertion and deletion of a doubly linked list. A C program for insertion and deletion. Insert a node into a doubly linked list and delete a node from a doubly linked list. So our program is starting with stdio.h and stdlib.h, and this is our structure for our node. So our node contains the previous address value and the next node address value, and also for data, saving the data, it is an integer data type. Okay, and we are just initializing a pointer, head pointer, and this is all our functions: insertion beginning, insertion last, insertion specified, and insertion deletion beginning, deletion last, deletion specified, and its display and search. So let's start our void main function, and the choices for entering our choice, and this is our menu items, and here we are choosing our particular operation. A, 1 is for insert in beginning, 2 is for insert at last, 3 is insert at random, like that. We are giving all the options and we are scanning our choice, and this choice is 1 is for insertion beginning case, 2 is for insertion last. Okay, we are using switch case here, and 3 is for insertion specified at a specified location, and 4 is for deletion beginning, 5 deletion last, 6 deletion specified, and 7 is for search a particular item in the doubly linked list, and 8 is for display, and 9 for exiting from this loop. Okay, and we are not entering a correct value. Please enter valid choice option is there in the default case of our switch. Okay, so our function is starting. Our first function, insertion beginning. So insertion beginning means we are inserting a node at the beginning place, okay, as a first node. For this we are declaring a pointer to a node, struct node start ptr, and item for accessing the item for our new node. Okay, so after this execution we will get the correct memory for our each node. Struct node malloc size of struct node, so we will get 6 bytes, 6 byte for one node, because 2 bytes is for saving the data part and 2 bytes for storing the previous node address, and 2 bytes for storing the next node address. Okay, if ptr equal to null, we can print overflow. Maybe the memory is not there is no free memory to allocate for our node, so ptr should be null. At that time we will print overflow. Otherwise, this is after the else part. Actually the node, in the else part we will storing the data into our each node. Okay, so enter item value, we are scanning the item value, and if head equal to null, because maybe there is no node at all at this time, we are inserting as a very first node, at that time head should be null. So if head equal to null, ptr next also null, and ptr previous also null, because there is no previous node and there is no next node, and the ptr data should be our item value, and we are pointing the ptr to our head. Okay, so at this point, okay, so this is our head pointer. Let's assume that this is our head. Okay, so when we are inserting as a very first node, our data should be 10, and there is no next value and there is no previous address, because only one node should be there. Okay, so the address part also null, and the address part of the next node, previous ptr next, this is ptr next also null, and ptr previous also null. Okay, now so after executing we are printing just node inserted. Okay, then if we are inserting a node as a last node, okay, we want to pointer ptr and temp and item, and after malloc statement ptr equal to struct node star malloc size of struct node. After this statement execution we will get the memory space for our next node. Okay, if ptr equal to null, we are printing overflow. Otherwise we are inserting that new node. Okay, so enter the value, item is there, so the ptr data should be item. Here also we are checking if head equal to null, maybe there is no node at all. If the number of node is 0 still, then we are inserting as a very first node. Okay, so ptr next also null, and ptr previous also null, and head equal to ptr. Else temp equal to head. So if we are inserting as a last node, we want to travel up to the last node. Okay, so for that we are pointing the head to the temp and we are traveling to the very last node, temp next, while temp next not equal to null, temp equal to temp next. So after exiting from this while loop, our pointer temp should be pointing to the last node of our linked list. After that we are inserting our pointer to the new last node. Okay, so for that we are editing the temp next value to temp next value equal to ptr previous equal to temp, and ptr next equal to null. Okay, so let's see. Let's assume that our linked list is like this. So this is our first node and second node, third node and fourth node. So we want to insert a new node as a very last node. Okay, so if we want to travel from here to here, for that we are declaring this temp. Okay, so first temp is pointing to our head. After that we are traveling to the very last node, like temp next not equal to null. So the while loop is executing when we have reached here. Okay, so temp next not here, temp next equal to null. So at this time our temp is this node. Okay, now our ptr is this. We are entering the new value to our ptr, 13 or 14. Okay, and we want to connect this last node, or we want to insert this node as a very last node. Okay, so for that our temp next, now the temp next is null, but now the temp next is contains the value of 104. Okay, so we want to erase this null value, and so this temp next, so temp next equal to ptr means the ptr is 104, the address value. So now the temp next should be 104, and this is our ptr. This ptr previous pointer is now pointing to 103. So this is our temp. So the ptr previous equal to temp. So now the ptr previous address value should say 103. Okay, store 103. Now the ptr is our last node. So the ptr next is null. Ptr next is null. Now our last node is our ptr. Okay, so this is the insertion of node in last. Okay, and after we are printing node inserted. Now insertion in the specified place. For that we are also need two nodes and item location I for traveling to that particular location. Okay, then this is for allocating the memory for each node, struct node, malloc, size of struct node. If ptr equal to null, we are printing overflow. Otherwise, we are inserting the new node at the correct specified location. For that, we want to travel to that location. We are pointing head to our temp and enter the location. Which location we want to insert the new node. We are entering this location. So we want to travel up to that place. Okay, this is the for loop for traveling to that place. So if I equal to 0, I less than location I plus plus, temp equal to temp next. After executing this for loop, we will reach the correct place, and maybe sometimes we are entering the LOC value that is maybe not in the correct value. At that time temp should be null. If temp equal to null means the location is not there. We have not entered the correct location. So at the time there are less than %d elements. Maybe we are entering only 3 nodes are there and we are entering the LOC value as 7. We want to insert as a 7th node. That is not possible. At that time we are printing there are less than that much of elements, and we are returning from this function. Okay, after that we are enter the value and we are scanning the item. So print data equal to item, and this is the insertion statement. So print ptr data is item and ptr next equal to temp next, and ptr previous equal to temp, and temp next equal to ptr, temp next previous equal to ptr. This is the first state more updating the address value of all the 2 nodes. So in between that 2 nodes we are inserting our new nodes. Let's explain with an example. Okay, let's assume that this is our head pointer. So 100, 101, 102 and 103 and 104. These are the address location of each node, and so the head is pointing to 100. So our data is like 10, 11, 12, 13 and 40. So this is our last node. This is containing, so 101 is here, and this is null value because there is no previous node. Here the value is 100 and there the value is 102. Next node, here 101 and this 103. This is 102 pointing to the previous node, and this is 104, this is 103, and this is null value. Okay, so this is our link part. Now we want to insert, let's assume that we want to insert in between this two node. Okay, this two node. For that, so after executing this PTR statement, after executing this PTR malloc statement, we will get a node like this. Okay, a space like this for entering the value and for the previous node connection and the next node connection. Okay, so this is our PTR. This is our PTR. So after we are entering the location, so if this is our if we are entering the location, we are entering like this is the index value 0, this is 1, this is 2, and this is 3, and this is 4. Okay, so we want to insert a node, insert the node after our two node, as a third position, so we want to, so here we are entering LOC as 3, so for that we want to travel till here. Okay, till 3. So I equal to 0, I less than LOC. So this for loop is executed up to LOC. I is less than LOC. That means up to 2. Now the head is pointing to this value. Now temp equal to temp next, and now the point is here. Then temp equal to temp next. Now the point is here. So the LOC values I values 2. After that LOC we are entered 3 because we want to insert the element. Insert the new node as our node with the index 3. Okay, so I less than 2 is less than 3. So at that time we have reached here. Now I equal to I plus plus. So I now 3 node less than 3. So now our temp is pointing to our node number 2. Temp is pointing to node number 2. Okay, now we want to insert this new node as after our temp. Okay, so for that, so now we are entering the value. Now we are saving the item value to the PTR data. PTR data equal to item. So PTR data, if the item is like 20, let's assume that 20. So 20 should saved here. After that PTR next equal to temp next. So this is our temp and this is our temp next. Okay, this is our temp next. Then temp next means this is the temp next, that is 103. Okay, so the PTR next equal to temp next means so temp next is 103. So the after the execution PTR next equal to temp next. So PTR next equal to temp next means now the 103 is like this. So we will get the connection to here. Now we want to update the 103 also. Before that we are updating PTR previous. PTR previous equal to temp. Our temp is 102. So we are saving PTR previous equal to 102. So we will get this connection also. Now we want to update one more point, that is temp next previous value. This is our node temp next previous value. Temp next previous node connection. So temp next previous connection should be PTR. So temp next previous. So the 102 is updated as PTR. PTR is, let's assume that 200. So this is updated as 200. Before that we also updating temp next equal to PTR. So this is our temp next. Now the temp next is not 103. Now the temp next is 200. Now the temp next is also 200 PTR. Okay, temp next is 200. We are updating this portion also. So after the execution of 1, 2, 3, 4, 5 statement, the node should inserted in this correct place. Okay, so this is the insertion specified function. After that, this is for deletion beginning. Deletion, here also if head equal to null, because there is no head equal to null means there is no node to delete, so print of underflow. Otherwise, if head next equal to null, head next is null is means in this case there is only one node, that means head next equal to null. At that time we are updating head equal to null and we are free head. Free head means we are deallocating the memory and node deleted. Otherwise, PTR equal to head we are deleting the first node. So head equal to PTR. PTR equal to head means we are pointing the head to now PTR. Then head equal to head next. Head equal to head next means now the second node is treated as the first node. Head equal to head next and head previous equal to null node. and free PTR. So this is the deletion case, and deletion last also, if head equal to null, printf underflow. If head next equal to null, next head next equal to null means there is only one node is there, so we want to delete that node. Statements are like head equal to null, free head. So because after the deletion there is no node. Okay, this is not while, it is while PTR next not equal to null, PTR equal to PTR next, and PTR previous next equal to null, and free PTR. In this case, let's assume that we are deleting, this is our head part, our value 10, 11 and 12. Easily I am placing ABC for our address value. So B is located here and this is null value. A is here and C is here and B is here, and this is our null value. So we want to delete this particular node. For that we want to travel till here. Okay, so PTR next not equal to null, PTR equal to PTR next. After this while statement we have reached here. Now we want to do like this, PTR previous. This is our PTR previous. Okay, so this is our PTR previous B. So locate the B next value. PTR previous next should be null. Okay, so there is no connection. We are deleting this connection, and now this PTR is free. Free PTR means now this PTR is not in the list of our doubly linked list. Okay, so and then node delete. After that we are deleting from the specified by using a data. Delete a node with a particular data. So the enter the data after which the node is to be deleted. So we are entering that value and we are traveling to that particular location. PTR equal to head, PTR data not equal to wall. We are traveling to that particular position, and PTR equal to PTR next. So let's assume that we want to delete the node of 11. Like we want to delete a node after the node value is 14. So we want to delete 11 node is here. Let's assume. Okay, so if we want to travel till here. For that there is a while loop. PTR data not equal to wall, PTR equal to PTR next. So we will reach the glitch here with the node value is our val. Okay, so after that we want to delete the next node. So let's assume for that we are just, let's see. So our val is now, in this example our val is 13. Okay, so we want to delete in this particular case the 13 is the last node. So we want to delete a node after the 13 node because there is no such node. So at that time, if let's for that this if is we are using, if PTR next equal to, so now we are reached here with this node. So now our PTR is pointing to this node. So the PTR next equal to null. Here the PTR next equal to null because there is no other node after the node PTR. Okay, so we are just printing can't delete. Okay, otherwise maybe if PTR next equal to null, maybe let's assume that there is another node 14 and it's DE. Okay, so D is pointing to here and this is our null value and this is pointing to here also. Okay, so we want to delete our last node. So we are just saying that we want to delete the node E after the node with the 13 value. Okay, so this is our last node. So we want to update this PTR is our last node. For that this else if statement is there. If PTR next equal to null, PTR next equal to null, we are just updating PTR next equal to null. Okay, so this is our PTR. So we are updating PTR. We are updating our PTR next equal to null. Otherwise, if the okay, so we want to delete a node after the value 13. So we want to delete this node. So this is not a last node or this is not a first node, like that. For that our execution statement is like this, temp equal to, so for that we want initialize one more pointer. Now our PTR is pointing to this node. Okay, so we want to point our temp equal to PTR next. So the temp is pointing to PTR next. We want to delete this node, is it? So now we want to change. So temp next is E, is it? Temp next is E. We want to update D and we want to change D as E because we want to connect this to here. So for this statement is that PTR next equal to temp next. So PTR next is now not D, it is E now. This is pointing to this node. Now also we want to do like temp next previous. See, This is our term next. Term next previous value is node D now. So we want to delete this particular node. So we are updating D, and now we are D as updated with the C. Okay. So that is here PT term next previous equal to PTR. Now we can delete this term, free term. Then node is delete. Okay. So this is for deleting a node with a after a specified data. Now this is for display. It is very easy for just display like printf PTR data and PTR equal to PTR next. We will print all the data. After that, this is for searching a particular item. For that also we are entering a pointer. We are entering an item and we are traveling from the head pointer. So we are pointing to the PTR equal to head. If PTR equal to null, that means list is empty. Otherwise, we want to search. Enter item which you want to search. We are entering an item. And if PTR not equal to null, up to PTR not equal to null, we are checking each node. If PTR data equal to item, if that current node contains our data, we are just printing item found at location, this much location, I+1, okay, first location or second location. Then we are changing the flag equal to 0 and we are breaking from there. Otherwise, we are setting the flag equal to, maybe the first node not containing our item, this else part should execute and flag equal to 1, and this will execute till PTR not equal to null. If we have found, we will break from this loop. Okay. So after we flag equal to 1 means we didn't find that node with that particular data. So at that time we are printing item not found. Okay. So this is all about this old program. This is a very lengthy program. Okay. Okay. So we are executing dll.exe. Okay. So the main menu is insert in beginning, insert at last, insert any like that we are entering. So 1, we are inserting first node. So node inserted. Again we are inserting 11 value. Okay, 11 inserting as a very first node. Now we are choosing a insert at last 2. Okay, so we are entering the value 13. Okay, so now our doubly linked list contains 3 nodes. Let's show it. Where is our 11, 12 and 13. Okay, so and now insert at any random location, like we want to insert after 12, that means 0, 1. Okay, after 1 we want to insert. So we are entering 3 option. We want to enter after second node. So enter the value like 100. Okay, now we will display here. See, after 12, 100 should be here. Okay, now we want to delete from the beginning. From the beginning is option is 4. Now 11 should be deleted. Okay, see, 11 is not here. Okay, so if we want to delete from last means 5, option 5. So enter your choice 5. So we will delete the last node. So our linked list contain 23, 14 and 3 in this particular programming execution. So after that, the 13, the last node should be deleted. Okay, so 23 and 14. So this is all about our doubly linked list program. Thank you.